Okay, Hartman, welcome back to this video series on the Cisco ASA firewall. Setting up device name and passwords. The default device name, also known as the host name of a security appliance, is Cisco ASA. It is highly recommended that you set a unique device name to identify the security appliance on the network. Additionally, networking devices usually belong to a network domain. A domain name appends the unqualified host names with the configured domain name. For example, if the security appliance tries to reach a host SecWeb by its host name and the configured domain name on the security appliance is securemeinc.com, then the fully qualified domain name FQDN will be secweb.securemeinc.com. In a new security appliance, you can configure the telnet and enable password. The telnet password is used to authenticate remote sessions either via the telnet or SSH protocol discussed later in this chapter. By default, the telnet password is Cisco. For the SSH sessions, the default username is PIX. The enable password, on the other hand, gives you access to the privileged exec mode if you are on the user mode. The enable password is also used for ASDM user authentication. There is no enable password by default. To configure the host name, domain name, and the telnet enable passwords via ASDM, navigate to Configuration, Device Setup, Device Name, Password, and specify the new settings. As shown in Figure 310, the host name is Chicago and the domain name is securemeinc.com. If you want to configure a new telnet and or enable password, select the appropriate, change the telnet and or enable password option and specify the current and the new passwords. In Figure 310, both passwords are set to C1C0123 masked. So you can see here Figure 310, configuring host name, domain name, and local passwords. Configuring an interface. Cisco ASA 5500 appliances come with a number of fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet interfaces. They also include one management interface, management 0/0, in all one rack, unit 1 or U models, and two management interfaces, management 0/0 and management 0/1 in ASA's 5580s. Additionally, you can create one or more sub interfaces off each physical interface. The fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet interfaces are used to route traffic from one interface to another based on the configured policies, whereas the management interface is designed to establish out-of-band connections. Configure data passing interface. Cisco ASA protects the internal network from external threats. Each interface is assigned a name to designate its role on the network. The most secure network is typically labeled as the inside network, whereas the least secure network is tagged as the outside network. For semi-trusted networks, you can define them as demilitarized zones, DMZs, or any logical interface name. You must use the interface name to set up the configuration features that are linked to an interface. The security appliance also uses the concept of assigning security levels to the interfaces. The higher the security level, the more secure an interface is. Consequently, the security level is used to reflect the level of trust of this interface with respect to the level of trust of another interface on the Cisco ASA. The security level can be between 0 and 100. Therefore, the most secure network is placed behind the interface with a security level of 100, whereas the least secure network is placed behind an interface with a security level of 0. A DMZ interface can be assigned a security level between 0 and 100. The Cisco ASA enables you to assign the same security level to more than one interface if communication is required between the hosts on interfaces at the same security level. Use the global configuration, same security, traffic, permit, interface command. Additionally, if an interface is not assigned a security level, it does not respond back at the network layer. The most important parameter under the interface configuration is the assignment of an IP address. This is required if an interface is to be used to pass traffic in the layer 3 firewall, also known as routed mode. An address can be either statically or dynamically assigned. For a static IP address, configure an IP address and its respective subnet mask. The security appliance also supports interface address assignments through a dynamic host configuration protocol, DHCP server, and via PPPoE, assigning an address via interface. You can also inform the security appliance to use the DHCP's server specified default gateway as the default gateway route if the obtain default route using DHCP option is enabled on ASDM. To configure a physical interface on a security appliance via ASDM, navigate to Configuration, Device Setup, Interfaces, select an interface and click the Edit button as shown in Figure 311. The physical Gigabit Ethernet 0/0 interface is configured as the outside interface with a security level of 0. The static IP address is 209.165.200.225 with a subnet mask of 255.255.255.224. The Enable Interface box is checked to activate the interface. In the example 3.9, the administrator enables the Gigabit Ethernet 0/0 interface as the outside interface and assigns a security level of 0. The IP address is 209.165.200.255 with a subnet mask of 255.255.255.224. So you can see here configuring a physical interface with an IP address. ASDM enables you to configure speed, duplex, and media type on an interface. If you click an interface's configure hardware properties, by default, the speed and duplex are set to auto and can be changed to avoid link negotiations. If the speed and duplex settings do not match the speed and duplex settings on the other end of the Ethernet connection, you see packet loss, which results in performance degradation. The media type is either RJ45 for copper-based interfaces or SFP for fiber-based interfaces. RJ45 is the default media type. As demonstrated in using example 3.10, the outside interface is set up with a connection speed of 1000 Mbps using full duplex mode. The security appliance shows the output of interface-related statistics when you issue the show interface command from the CLI as illustrated in Figure 311. Gigabit Ethernet 0/0 is set up as the outside interface and has an IP address of 209.165.200.225, whereas Gigabit Ethernet 0/1 is set up as the inside interface with an IP address of 192.168.10.1. This command also shows the packet rate and the total number of packets entering and leaving the interface. You can see here and here's more of the output. Configuring a sub interface. Cisco ASA has a limited number of Ethernet-based interfaces depending on the platform you are using. However, you can divide a physical interface into multiple logical interfaces to increase the total number of interfaces. You do so by tagging each sub interface with a unique virtual VLAN ID, which keeps the network traffic separate from other VLANs using the same physical interface. The security appliance uses the IEEE specified 802.1q trunking to connect the physical interface to an 802.1q enabled device. The number of VLANs sub-interfaces can range from 3 to 250 depending on the security appliance model and the license key used as shown in table 3.3. VLAN ID must be between 1 and 4094, whereas the sub interface must be an integer between 294 967 295. Although the sub interface and the VLAN ID do not have to match, it is a good practice to use the same number for ease of management. To create sub interfaces via ASDM, you can go to Configuration, Device Setup, Interfaces, select a physical interface and click the Add button as shown in figure 3.12. The administrator is creating a sub interface from a physical gigabit Ethernet 0/0 interface. The sub interface number is 300 and is linked to VLAN 300. A static IP address of 192.168.20.1/24 is configured for this sub interface. So you can see here configuring a sub interface. Example 3.12 demonstrates how to create a sub interface 300 of gigabit Ethernet 0/0. It is linked to VLAN 300 and configured with an IP address of 192.168.20.1/24. So I'll just go through this here. Table 3.3 supported sub interfaces on the security appliance model. License feature, maximum number of VLANs. ASA 5505 base 3, ASA 5505 security plus 20, ASA 5510 base 50, ASA 5510 security plus 100, ASA 5520 base 150, ASA 5540 base 200, ASA 5550 base 250, ASA 5580 base 250, ASA 5580 40 base 250. And here you go, creating a sub interface. You can see here. Configuring a manual interface. All Cisco 1RU security appliances have one built-in management 0/0 port, whereas the 5580 appliances have two built-in management 0/0 and management 0/1 interfaces. These interfaces are designed to pass management-related traffic only. The management interface blocks all the traffic that is trying to pass through it and permits only traffic destined to the security appliance. This ensures that the management traffic is separate from the data traffic on an appliance. Any gigabit Ethernet or fast Ethernet interface can act as a dedicated management interface. When this interface for management only option is configured within ASDM, or the management only command is issued from the CLI. Some general characteristics about management interfaces include the following. Routing protocols such as RIP and OSPF are supported on a management interface. A sub interface can act as a management interface if configured to do so. Multiple management interfaces are supported on an appliance Traffic through the security appliance is dropped on a management interface and a syslog message is generated to log this event. VPN tunnels for remote management are allowed to terminate on a management interface. As shown in example 3.3, the management interface 0/0 interface is set up as a management-only interface with an IP address of 172.18.82.64/24 and the security level is 100. DHCP services. Cisco ASA can act as a DHCP server to distribute IP addresses to the end machines that are running DHCP client services. This feature is particularly important if you have a small branch office that does not own a dedicated DHCP server. To configure the DHCP server via ASDM, go to the Configuration, Device Management, DHCP server and select the interface where you want to enable the DHCP services. ASDM opens a new window where you can define the following attributes. Enable DHCP server. The first thing in setting up the DHCP server is to enable it on the selected interface by selecting the Enable DHCP server checkbox. DHCP address pool. You must define a pool of addresses that can be assigned to a DHCP client. Specify a start and an end IP address for the DHCP pool. The network addresses need to be on the same network as the address assigned to the interface. Optional parameters. Cisco ASA enables you to set up a number of useful DHCP parameters such as WINS and DNS addresses, domain name, lease length, and the ping timeouts. The DHCP server sends the WINS, DNS, and domain name when an address is offered to a DHCP client. The client computers do not need to be manually set up for these addresses. If the ping timeout is configured, the security appliance sends 2 ICMP request packets to the address it is about to assign. Before it allocates the address to a DHCP client, it waits for 50 milliseconds to receive an ICMP response. If a response is received, the security appliance assumes that the address is being used and thus does not assign it. If a response is not received, the security appliance allocates the IP address until the DHCP lease expires. After the lease expires, the DHCP client is expected to return the assigned IP address. You can change the default lease time setting 3600 seconds by specifying a value in the lease length box. Enable auto configuration from the interface. In many network implementations, the security appliance acts as a DHCP client on one interface and a DHCP server on another. This is usually the case when the security appliance gets an IP address from the ISP's DHCP server on its outside interface. At the same time, it acts as a DHCP server to assign addresses to the DHCP clients connected on the inside networks. In this network scenario, the security appliance can pass the DNS, WINS, and domain name information to the DHCP clients after it receives those attributes from a DHCP server that resides on its interface, acting as a DHCP client. You can enable this feature by selecting Enable Auto Configuration from interface box and specifying a DHCP client enabled interface such as the outside advanced. The security appliance enables you to assign DHCP option codes ranging from 0 to 255. These DHCP option codes are defined in RFC 2132 and can be set up on the security appliance if you click the advanced option. For example, the DHCP option code 66 TFTP server is assigned to the DHCP clients with a TFTP server address. This DHCP option is typically used by the Cisco IP phones to retrieve their configuration from the TFTP server. In figure 313, a DHCP server is enabled on the inside interface with a pool of addresses that start at 192.168.10.100 and ends at 192.168.10.200. The optional parameters are configured where the DNS address of 192.168.10.10, WINS address of 192.168.10.20, and a domain name of securemeinc.com are sent to the DHCP clients. The ICMP ping timeout is set to 20 milliseconds and a lease time of 86400 seconds, 1 day, is defined. The DHCP auto configuration is not enabled. Example 314 shows that DHCP service is enabled for the inside interface with the address range from 192.168.10.100 to 192.168.10.200. The assigned DNS and WINS addresses are 192.168.10.10 and 192.168.10.20 respectively. A DHCP option code 66 TFTP server is assigned to the DHCP clients with a TFTP server address of 192.168.10.10. So you can see here example 3.4, configuring DHCP service on the inside interface. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.